everyone. Today we are going to learn about oxidation numbers. Each and every element exhibits oxidation state in various compounds. Sometimes a single element exhibits various oxidation states in different compounds. So let's get into detail. Here first alkali metals, the 1A group elements, they exhibit oxidation state +1. They always exhibit oxidation state +1. Suppose for example there is a compound NaCl, sodium chloride. Sodium is alkali metal, so it exhibits +1 oxidation state. All the alkali metals such as sodium, potassium, hydrogen, lithium, these exhibit +1 oxidation state. And coming to halogens like fluorine, chlorine, bromine and iodine, they exhibit -1 oxidation state. -1. And coming to oxygen family, they exhibit -2. And next, when we go from right to left, -1, -2, -3, and it happens. So all alkali metals exhibit +1 oxidation state and the halogens family exhibit -1 oxidation state. Alkaline earth metals, they exhibit +2 oxidation state. For example, magnesium chloride, MgCl2. It exhibits +2 oxidation state. +2 oxidation state. Magnesium, beryllium, these exhibit +2 oxidation state. Suppose if we have to find oxidation state of chlorine. So here we know the oxidation state of magnesium +2. So 2 plus, there are 2 chlorines, right? 2 into, let's suppose think the oxidation state of chlorine is X. So X is equals to 0. The entire compound becomes 0. So 2x is equals to -2. X is equals to -1. And we know that chlorine's oxidation state is -1. Chlorine also exhibits positive oxidation states such as +1, +3, +5 and +7. But its fixed oxidation state is -1. And coming to homoatomic elements, these are the single elements like sodium, helium, just single. For those oxidation state is always 0. Like suppose a homoatomic elements like H2, it doesn't form any compound, it's just an element. So its oxidation state is 0. H2, P4, they didn't form any compound, right? So its oxidation state is 0. And coming to oxygen, I have said earlier that some compounds, some elements, they form different oxidation states with different compounds. Like for oxide, the oxidation state of oxygen is -2. It's general. Oxygen oxidation state is -2. For peroxide, it's -1. For superoxide, it's -1/2. Oxide example is K2O. Potassium oxide, it's K2O is potassium oxide. In this, the potassium's oxidation state is +1. So 2 plus X is -2. Oxygen, it is oxide. Peroxide, if there are 2 oxygens linked side by side, this bond is known as peroxy bond. Now this bond is known as peroxy bond. -1, K2O2. We say, right, hydrogen peroxide, H2O2, has similar K2O2. It's potassium peroxide. In this potassium peroxide, oxidation state is -1. And superoxide, it's KO2. This is potassium superoxide. In this compound, oxidation state is -1/2. Coming to hydrates, actually hydrogen has a dual nature. It behaves as a cation and anion both. It has hydrate properties. So it also exhibits -1 oxidation state. It also exhibits -1 oxidation state. Example is hydrazine, N2H4. In this compound, hydrogen exhibits -1 oxygen state because it is a hydride here. Now the important note is that oxidation number of an element does not exceed its group number. It does not exceed its group number. Now let's see an example how to calculate oxidation state. H3PO4. H3PO4, it is orthophosphoric acid. Now we have to calculate the oxidation state for phosphorus here. We don't know the oxidation state of phosphorus. So how to calculate? For hydrogen it's 3 because it is not hydride here, it is +1 here. So 3 into +1. Now let's take phosphorus X. We don't know, we have to calculate X here. So X plus oxygen we know, -2. -2 into 4, it's -8. And total for the compound it's 0. So is equals to 0. 3 minus 8 it's -5. So X is equals to 5. The phosphorus oxidation state in this compound is 5. Now coming to this note, we'll see an example how this valid here. Coming to CrO5. Now let's check. We want to know the oxidation state of chromium here. Let's keep it as 5 or X. X minus 10. Because oxygen's oxidation state is -2. -2 into 5, it's -10. We have only 8 groups here. Now we got here 10. The oxidation state of chromium is 10. It's not right. Because we have only 8 groups and the chromium's group number is not 8. The chromium's group number is not 10. The chromium's group number is 6. Now we'll see how we have to calculate it. Draw the structure of chromium, this CrO5. This is popularly known as butterfly structure. For some compounds, you have to remember these structures. There are 5 oxygens. I have discussed earlier that if the bond exists like this, oxygen side by side bond, then this bond is called peroxy bond. In that case, oxygen exhibits -1 oxygen state, not -2. So, except this oxygen, every oxygen here exhibits -1 oxygen state. And for this, it is -2. So now let's calculate X -2 -4. Why -4? 4 oxygens into -1, -4 is equals to 0. X is equals to 6. So chromium's oxygen state is 6 here. And unfortunately 6 is its group number. So this is how you calculate oxidation numbers. If you want me to make detailed videos on this oxidation number and various examples, just comment down below in the description comment box. Don't forget to like and share it with your friends. Subscribe. Thank you.